Hello everyone, welcome to Vishnu's lectures. So today we are going to discuss type conversions or typecasting. This is the last concept in data types concept. So before discussing about type conversions, you should have a basic idea about what is operator and what is operand. Okay. So what is operator? Operator is a symbol. Operator is a symbol which is meaningful to the compiler. So what is operator? Operator is a symbol which is meaningful to the compiler. Example, plus, minus, multiplication, modulus, etc. So all these are treated as operators. What is operand? See here, A plus B. Here plus is a operator. A and B are operands. Similarly, X minus Y. X and Y are operands. Minus is an operator. And B greater than C. Here greater than is an operator. B and C are operands. So I hope you are clear what is operator and operands. See here. Next up, what is typecasting? What is typecasting means? If two operands using arithmetic operator must be of same type. Two operands using arithmetic operator must be of same type. Means consider A plus B. A is integer and B is integer. Here no problem. Addition will happen simply. But observe case 2. A plus B. Here if A belongs to int and B belongs to char. In this case, the addition operation will not be performed because both operands should be under same type. Then only the operation will be performed. But here A is belongs to integer, but B is belongs to character. In this case, one of the operand should be converted to other type. Means here char should be converted to integer for the time being. This is called implicit typecasting. So this implicit typecasting is done by the compiler. So this char will be typecasted to integer, or you can say it is promoted to int by the compiler. Getting my point? Simply, if you are doing any operation, both operands should be same type. Otherwise, the compiler will convert one of the operand to other type. That is the thing. So, if two operands are not belongs to same data type while performing the any operations, then compiler converts one operand to other type. Very important note. It is temporary conversion for performing that operation only. Original data is unaffected by the typecasting. Means even though if you typecast one of the data type, the original data cannot be affected. We'll discuss practically. So here, typecasting. Typecasting is divided into actually two types. One is implicit typecasting and explicit typecasting. First, we'll discuss what is implicit typecasting. So what is implicit typecasting means? Typecasting done by the compiler is called implicit typecasting. Implicit typecasting is a type. So implicit typecasting is upper typecasting. Means that is promoting to upper type. Consider if you are doing any operation between char and int, then lower type should be typecasted to upper type. So which is the lower type and which is the upper type here? Char is the lower type, int is the upper type. So char should be converted to int. If you are doing any operation between int and float, then here between int and float is higher type, int is lower type. So that's why if you are doing any operations between int and float, int should be typecasted to float. If you are doing any operations between float and double, then float should be typecasted to double. Who will typecast this? Means compiler will typecast. That is called implicit type conversion. Next example for implicit typecasting. Observe here. So int x equal to 10, float y equal to 2.5, float z equal to x plus y. This I already wrote in the Ubuntu. We'll check it. Vi space code1.c. So observe here. So x equal to 10, int x equal to 10, float y equal to 2.5, and float z equal to x plus y. See, you are doing addition operation here, right? Observe, while doing any operation, you have to check is both the operands are under same type or not. What is the data type of x? Data type of x is integer. What is the data type of y? Data type of y is float. Is it possible to perform the addition operation? No, because both operands are different types. So what happened here? The lower type should be converted to upper type by the compiler. So what is the lower type here? X is the lower type compared to int and float. Int is the lower type. So int should be promoted to float. Lower type should be promoted to higher type. So now what happened here? X is typecasted to float. What is X value? X value is 10. So this is typecasted to float. When it is typecasted to float, the 10 should be typecasted as like this 10.0000. Okay. 10.0. So 10 in terms of float is 10.000 plus what is y value? 2.50000. After dot, we have to assume 6 digits. Okay. So now the addition will be performed like this. Now x is also float and y is also float. Now operation will be performed. Now the output should be 10.00 plus 2.500 means 12.500 will be assigned in Z. Getting my point? While you are adding x plus y, both you don't think while you are adding x plus y, x is integer type. No, x is implicitly typecasted to float. So while performing the addition operation, x and y are both are float only. Okay, and this typecasting is for temporary purpose. So here x is integer typecasted to float. So this type conversion is temporary. Means after typecasting, if you print x value, again x value is integer only. The typecasting from integer to float here is just a temporary purpose. I hope you are clear. Okay. Now execute. So output should be printed as 12.5. GCC space code1.c. Let me erase this. dot slash a dot out. So 12.5000. Getting my point? So what is the conclusion? Whenever you are doing any operations, both the operands should be same type. Otherwise, lower type should be converted to higher type by the compiler. That is called implicit type conversion. I hope this much clear. Now see one more important point here. Here, important note. But the scenario will be changed whenever you are using equal to operator. See here. When the equal to operator is used, right side operand should be typecasted to left side operand. When equal to operator is used, no concept of upper type conversion. Getting my point? See here, code 2.c. So int x equal to 10, float y equal to 2.5, right? And int z equal to x plus y. So here, what happened here? Same code is available here, code 2.c. Let's say vi space code 2.c. See here. So how to analyze this? First, int x equal to 10. Okay. Float y equal to 2.5. Int z equal to x plus y. So while you are doing x plus y operation, what happened? Both should be under same type or not? No, not same type, because x is integer here, y is float here. So what happened? This x will be typecasted to float internally by the compiler. This is called implicit type conversion. So x should be 10.00 plus y should be 2.500, something like this. Now the result is same, 12.5000, right? So now it is looking like this. Int z equal to 2.500. Now, when equal to operator is used, what happened? Rightmost data should be typecasted to leftmost operand. Rightmost operand should be typecasted to leftmost operand. Here, there is no concept of lower type should be converted to higher type. So what happens simply? What is the rightmost data here? Float should be converted to left side operand. No need to consider which is higher type, which is lower type. Simply blindly you can typecast rightmost to leftmost operand. What is the rightmost data? Float. So if you typecast this rightmost 12.500 to the left side operand, to the integer, then what happened? 12.500 in terms of integer is 12 only. Getting my point? So actually, what is the value going to be stored? It is implicitly 12.500 should be implicitly typecasted to left side operand, means left side operand is z, which is integer. So after 12.500 typecasted to integer, it should be 12, and the 12 is going to be stored in z. So what is z value stored? 12. So whenever you are using equal to operator, simply right side operand should be typecasted to left side operand. Getting my point? So now, what is z value stored as? Z value stored as 12 only, simply. I hope you are clear. Just executing this. Dot slash a dot out. See, you are getting 12 only. Okay. Next. We'll see one more example. Vi space code3.c. See here. Int x equal to 300, char ch equal to x. So what is x here? Integer. So x is integer and ch is character. So what happened? Rightmost should be typecasted to leftmost operand. Now x is typecasted to character. Now x is typecasted to character. So whenever you are trying to store 300 in terms of character, then what happened? So first of all, tell me char ch, it is signed char or unsigned char? It is signed char or unsigned char? This is signed char. So what is the range for signed char? The range for signed char is from minus 128 to plus 127. Is 300 existing in that range? Let's say you can take this as unsigned char. Let's take unsigned char. Unsigned char ch equal to x. So now tell me, what is the range for unsigned character? 0 to 255. But 300 existing in this range? Not existing. So what happened? I already told this concept in previous lectures. So what I have to do here? Taken value minus total values. So taken value is 300 minus total values in this chart means 256, which is equal to 44. Getting my point? So whenever you are trying to store x value into character ch, the rightmost should be typecasted to leftmost operand. This is applicable only when equal to operator is used. Only when equal to operator is used, rightmost operand should be typecasted to left side operand. In remaining all the cases, lower type should be typecasted to upper type. Getting my point? So what is the output printed in this case? Output printed as 44 only. Code3.c /a dot out. 44. Getting my point? Let's discuss one more example. Vi space code4.c. This is simple example. See here. 5.5. Now tell me 5.5 is which data type? 5.5 is a real data. That by default, the real data is double. I already told this point. So whenever you try to store 5.5 into A, now typecasting done. Whenever equal to operator is used, right side data should be typecasted to left side. What is right side data here? Right side is 5.5, left side is A, means integer A. So if you typecast 5.5 to integer, what happened? 5.5 is a double. If it is typecasted to integer, what is the answer? 5.5 in terms of integer is 5. So 5 is stored in A. Getting my point? Simply 5 is stored in A because here in this example, double 5.5 is double, that is typecasted to left side operand. What is the left side operand? Integer. So if 5.5 is typecasted to integer, the value will be stored as 5. So a value is 5. If I print a value, so 5 is going to be printed simply. Okay. Next, one more example. Code5.c. See here. In this example, 5 is integer, rightmost data operand is integer, and left side operand is float. In this case, what happened? Similarly, same way, rightmost data should be typecasted to left side operand. What is rightmost data? 5, which is integer, should be typecasted to left side. What is left side operand? Float. If 5 is typecasted to float, what is the answer? If integer is typecasted to float, if 5 is typecasted to float, 5 should be treated as 5.00. So in F, 5.00 will be stored because 5 is typecasted to float. So what is F value printed as? 5.00. GCC space code5.c /a.out. Getting my point? So all these examples are about equal to operator. When equal to operator is used, right side operand should be typecasted to left side operand. These are the examples for that. Okay. Next, vi space code6.c. See here, this is interesting. So here what happened? Unsigned int a equal to 5. So unsigned int a equal to 5. This is unsigned. Okay. Now int b equal to -2, comma c. C equal to a greater than b. C equal to a greater than b. Now tell me what is a? What is a? A is 5. What is b? -2. 5 greater than -2. True or false? Actually, it is true. True means 1, which is equal to c. So c value, if I print, it should be print 1. But interestingly, 5 greater than -2 is not 1. 5 greater than -2 is false. So it is going to be print 0, not 1. Interesting. Because 5 greater than -2, 5 is bigger value, -2 is smaller value. As we know that 5 greater than -2 is true, it is 1, so output should be 1. But it is not like that. See here. GCC space code6.c /a.out. Why 0 it is printing? Why the condition is false? Because I already told the concept. Whenever you are doing any operation, both should be under same type. See here, which operation we are performing here? Which operation you are performing here? 5 greater than -2. So you are doing one operation here. Which operation? The comparison. So whenever you are using any operator, both should be under same type. Is 5 and -2 under same data type? Of course, both are integer, but 5 is unsigned. 5 is unsigned integer. 2 is signed integer. 5 is unsigned integer. 2 is signed integer. So whenever you are doing operations with signed and unsigned, signed is a lower type and unsigned is a higher type. Now, -2 is typecasted to unsigned implicitly. So when -2 is typecasted to unsigned, in place of -2, the 4 giga value will be getting my point. So whenever you are doing any operation, both should be under same type. If not, then the lower type should be typecasted to higher type. Here the lower type is -2, which is signed. When -2 is typecasted to higher type, which is unsigned, then -2 should be equals to 4 giga. So the internally it should be compared like this. 5 is unsigned greater than 4 giga. This is typecasted to unsigned. Now both are unsigned. -2 in terms of unsigned is 4 giga. So what happened? The condition will be 5 greater than 4 giga value. Condition will be false, which is 0. That's why the output is getting as 0. I hope you are clear. Okay. Next. 0. Next. Now, so all these are discussed already. Explicit typecasting. What is explicit typecasting? See here, what is explicit typecasting? If the variable type is changed by the user, then it is called explicit typecasting. If the variable type is changed by the compiler implicitly, then that is implicit typecasting. If the variable type is changed by the user, then it is called explicit typecasting. Example, this one. See here. First, float z equal to 2.5. So 2.5 is a float. Now, what I'm doing here, I'm making this as a integer. If I write int before 2.5, now explicitly I'm typecasting this 2.5 to integer. Now 2.5 will be becomes as 2 because I typecasted this 2.5 into integer. And what is the value stored in z? The value stored in z is what? 2.00. See, don't confuse. Again, I'm telling. Anyway, this code 7.c is available in Ubuntu. There I will explain same program. vi space code 7.c. See here. So float z equal to 2.5. But what I did here, I typecasted this 2.5 into integer. Then what happened? This result will be treated as 2. Getting my point? So whenever I typecasted this 2.5 to int, the result will be 2. Now, this is step 1. In step 2, what is the result? Result like this. This is step 2. Float z equal to 2. This is step 2. So now I already told whenever equal to operator is used, the rightmost should be typecasted to left side operand. Now 2 should be typecasted to float. So 2 in terms of float. So at step 3, it should be like this. So when equal to operator is used, rightmost operand is should be typecasted to left side operand. That's why step 3 becomes like this. Float z equal to 2.000. So z value should be 2.000. Getting my point? cc space code 7.c. So 2.000. We'll discuss one more example on explicit type conversion. vi space code 8.c. Okay. See here, what I'm doing, int a equal to 5, float b equal to 2, int a equal to 5, float b equal to 2, float c, and c equal to a by b semicolon. First, we'll discuss same without typecasting. Don't typecast this. Here I'm typecasting this b value into int, right, explicitly. So I don't want to typecast this. Let's discuss this first, okay, without typecasting. So what happened here? Without typecasting, what happened here? What is a here? What is b here? What is a? A is 5. What is b? B is 2. And what is the operation I'm doing? Division operation. Any operation, whatever operation it is, addition or multiplication or division operation, whatever the operation it is, both operands should be same data type. Then only operation will performed. Otherwise, one of the data type should be typecasted to other type. Which one? Lower type should be typecasted to higher type implicitly by the compiler if you are doing any operation. Okay, now see, here A should be typecasted or B should be typecasted. Which is the lower type? A is the lower type because A is the integer. B is higher type because B is the float. So now A is promoted to float. When A is promoted to float, what happened? A is 5 should be typecasted to 5.00 divided by 2. 2 means float. So already it is float now. 2.00. Now whenever you are doing operation, both are same type. Now the output is getting as 2.5000. Okay, now it is looking like C equal to 2.500. Now tell me, what is C value? Means C belongs to which data type? C belongs to float. So equal to operator is there. When equal to operator is there, right side data should be typecasted to left side data. Right side data is also float. Left side data is also float. Now 2.5 in terms of float, left side, 2.5 only. That's why in this case, the output should be printed as 2.5. Getting my point? GCC space code 8.c. See 2.500. Getting my point? Okay. Again, what if while assigning the result, consider all the steps are same. Consider all the steps are same. But here, while I'm assigning this 2.500 to C, consider I want to change this C into integer. let's take in the code C value as integer. Then what happens? So whenever you take C value as an integer, the result is 2.500 only finally. But what happened whenever you are trying to assign this 2.500 to C, now the C is not float, now the C is integer. Now what happened? The C is integer now. This 2.500, which is float, is typecasted to integer. When 2.500 is typecasted to integer, now the value going to be stored in C is 2 only. Getting my point? Because whenever your equal to operator is used, right side data should be typecasted to left side operand. Right side data is 2.500, which is float. Now this is typecasted to left side. What is left side data type now? Integer. So if 2.500 typecasted to left side 1 into integer, the result should be 2. But while printing C value, you should be use correct format specifier, because C belongs to integer type. If C belongs to integer type, the format specifier used for C is %D. See here. Now printing 2 only. Getting my point? But now what I'm doing this time, let's make it float only. Do the same operation. But now what I'm doing, I'm typecasting this B into integer explicitly. Integer. So now what happened? So in this case, int a equal to 5, float b equal to 2, float c. Now c equal to a by, typecast it into b. Okay. Now what happened? What is b value? B value is 2. B value is 2. B is which data type? B is which data type? B is float data type. So B value is, if it is float data type, B value is 2.00. But I am typecasting this B value, which is 2.00, is into integer. When I typecast 2.00 to integer, what happened? It should be typecasted to 2. Explicitly I am typecasting. So here one of the operand is 2. Now what happened? A is which data type? A is already integer. So now both A and B are integer. A is already integer. Now B I typecasted to integer. So now A by B will be performed. Now tell me, in this is step 1. If you consider this is step 1 and this is step 2. While performing step 2, both A and B are which data type? Both A and B are integer data type. A is already integer data type, but B is float data type. I typecasted this into int. Now both A and B are integer data type. So simply remember, whenever the both operands is in integer, the result also getting in integer only. Very important point. So don't think that now 5 by 2 answer is 2.5. 5 by 2 answer is not 2.5. 5 by 2 answer is 2 only. Why 2 only? Why not 2.5? Because if both the operands are integer, the result coming is also integer. If both the operands are float, the result getting is also float. This is very important point. So both A and B are integer. The result will be not 2.5. The result will be coming in terms of integer. So A by B answer is 2.5, but in terms of integer is 2 because both operands are integer. If both operands are integer, the result coming is also integer. Getting my point? So answer is 2. In step 3, what happened? In step 3, C equal to 2. So now C is which data type? Float data type. Now 2 in terms of float, which is 2.000. So now C value printed as 2.000. I hope you are clear about this. So use correct format specifier because now C is float. So you have to use correct format specifier. See, the output is 2.000. Getting my point? Okay. And one more last and final example. We'll take code one only. Vi space code1.c. Okay. So in this case, what is the output printed? This is last and final example. Just concentrate. Int x equal to 10. Float y equal to 2.5. Float z equal to x plus y. Now tell me, this I already discussed, right? So here you are doing addition operation. While doing any operation, both operands should be same. Is both operands should be same? No. So lower type should be typecasted to upper type. Which is the lower type here? X is lower type, which is 10 should be typecasted to float. So 10.00 plus 2.500. That's why the result is 12.500. And while storing this value into Z. Now compare Z and 2.500, both same type. Z is also float and the result is also 12.5 same means float. So the answer is 12.500. But what if I typecast one of the operand here? Consider I'm typecasting one of the operand here. Which one? Why I'm typecasting to int? I'm going to typecast y value to int. So in this scenario, let's discuss. So here, now y is behaving as integer for the time being. And now tell me, what is x value? X value is 10 plus what is y value? 2.5. But you are typecasting this explicitly to integer. So y value is 2.5, now typecasted to integer. So 2.5 in terms of integer is 2 only. Getting my point? So the result is getting as 12. So in final step, float z equal to 12. So 12 in terms of float. So I already told that right side should be typecasted to left side operand when equal to operator is used. So 12 should be typecasted to float. So the result should be 12.000 if I typecast this explicitly. So y is typecasted to integer here. Getting my point. But this is temporary only. Don't think y is permanently typecasted to integer. Just for calculation, for calculate this x plus y is typecasted to integer. After this calculation, y is automatically float only. See here. After this operation, simply I'm printing y also. Y is float only after the conversion. So printf y equal to percentage f comma y. Okay. So what is the output printed here? So your typecasted y value into int. So 2.5 should be typecasted to 2. 12, 10 plus 2 is 12. So 12 is your storing in z values. So z value is float. So 12 is again typecasted to float. When 12 is typecasted to float, the z value is 12.000. And you are trying to print y value here at last. So what is the y? What is y value taken as? 2.5. So 2.5 is going to be printed. Sir, you typecasted it into integer, na sir. But the typecasting should be only temporary. For the time being, for only to perform x plus y only, y is acting as an integer. After this x plus y is automatically float only. That's why I already told you the type conversion are temporary and it is not affect the original data. That is the important point. Okay. So the expected output is 12.00 Z value and the Y value should be 2.500. See here. 12.00 and Y value is 2.500. Okay. I hope you are clear about this typecasting. And this is the last concept in data types concept. Next, we are going to discuss about operator concepts. Okay. Yeah. For more videos, please subscribe to our channel. And in next class, we will discuss, we will start operators concept. I hope you are clear with this. Thank you.